Mechanical and electrical designers needed a tool to speed up their oft-times arduous and time-consuming work. To fulfill this need, Ivan E. Sutherland of MIT's Electrical Engineering Department created a system for making a digital computer an active partner of the designer. The Sketchpad system was developed on the TX2 computer that was designed and built at MIT Lincoln Laboratory. It is a large-scale transistorized digital computer, especially adapted to input-output experiments such as Sketchpad. At the control console, the designer draws directly on the cathode ray display with his light pen. He uses a system of push buttons and switches to give the computer directly such instructions as delete a line or move a point. The word ink appears when there is no display to establish tracking of the light pen. The cross represents the point of a pencil. If the designer needs a bracket, he makes a rough drawing and then instructs the computer which of the lines should be horizontal and which vertical. The computer obeys the instructions and makes a neat-looking bracket. After a change of scale of the drawing, guidelines are added to indicate a hole in the bracket. Lines are made vertical and then dotted. The flick of the pen is a signal that the user is finished drawing a line. The guidelines are erased to complete the whole. Now the designer needs a rivet to fit in the hole of the bracket. The shank is drawn. A short circular arc is swung for the top. Lines are squared up and the rivet is completed. However, as length and diameter were not specified, the rivet dimensions can be altered on the display to fit various conditions merely by using the light pen. As the shape of the rivet has been stored in the computer memory, it is called up. The proper size selected, and the rivet slips into the hole. The rivet can become a subpicture, which can be individually sized and moved, or repeated as required by the designer. A change to the original drawing, such as erasing the two guidelines, is immediately shown on all subpictures. As the subpictures are entities in themselves, erasing any part, such as a shank line, erases the entire picture. The completed bracket with rivet may be used to make a series of subpictures and placed on a clean piece of paper, so to speak, in the location desired. This trio of brackets may in turn be used as a subpicture. Imagine the ease of this technique in making a complicated wiring diagram, where single components or whole units must be repeated over and over again. It is not always necessary to work at the same depth or number of repeats. A once repeated rivet may be placed on a drawing that has been repeated several times. Notice the tiny rivet on the bracket. With a range of scale factors of 2,000 to 1 available, this dot can be enlarged many times. In effect, you draw on a 7-inch square portion of an area 1/4 of a mile on a side. There's plenty of paper. By enlarging the drawing, very fine detail can be placed in position with ease and considerable precision. When the scale factor is changed, the computer recomputes what the display should look like at the different scale factor. As a Sketchpad drawing is completed, a paper tape is punched for use in a plotting system to reproduce the drawing when desired. While the Sketchpad concept is still in a developmental stage, work in this area is being carried on at MIT and Lincoln Laboratory.